Which of the following describes the set of values of a for which the curves x squared plus y squared equals a squared and y equals x squared minus a in the real xy plane intersect at exactly 3 points? Okay, so we are lucky enough to see that the first equation is clearly a circle and the second one is a shifted parabola. So we can just draw this. And we've learned our lesson from that earlier problem. Learned our lesson from this one, that graphing it is quite powerful. So the first equation is like this. That's the circle, and importantly, it passes through 0, negative a. And the second equation is y equals x squared minus a, which looks like that. And we're trying to find the set of values a for which the curves x squared plus y squared equals a squared and y equals x squared minus a intersect at exactly 3 points. So we are guaranteed that we have at least one intersection point at 0, negative a. But otherwise, our main problem is that like once this parabola passes by, the parabola is not gonna curve back in. That's impossible. It's also not going to go like that. Why exactly it won't, I'm not entirely sure. That just seems absurd. Yeah, like the parabola is gaining speed. Once it passes, it passes for good. Yeah. So what our main problem is we're trying to figure out if the parabola goes under like this, because it's definitely possible for this to happen. Or if it'll go up and it'll intersect. So the way we figure this out is for very small x. For small x, we want to have x squared minus a. So the parabola, we want the parabola to be above the circle. If you know calculus, what I'm doing here is basically like a related rates taking the derivative, but I'm going to do it manually. It's basically what I'm doing here is I'm trying to figure out, like at 0, does the parabola or does the circle have a steeper like slope of the curve? And if the parabola has a steeper slope, it will be above, and then it'll hit like over here. So we want the parabola to be above the circle. And all right. So how do we figure this out? We square it. So x squared minus a squared. We actually end up having to flip the sign, unfortunately, because both of these numbers are negative. And so like negative 4 is greater than negative 5. But when you square it, like negative 4 is greater than negative 5, but when you square it, you have that 4 squared is less than 5 squared. So that's why we're flipping the sign here. We expand x to the 4th minus 2ax squared plus a squared is less than a squared minus x squared. We go wapow and rearrange. So we want this to be true for small x. And it was actually really nice that we have that. This is symmetric for x and negative x. And so for small x, x to the 4th will be for like sufficiently small x, like when we've just left the origin, x to the 4th is much smaller than x squared. So our main problem is that we have to have that 2a minus 1 is, as long as that's greater than 0, we're good. And so if we want 2a minus 1 to be greater than 0, we need to have that a is greater than half. And look at that, that's option E. Yay. So yeah, we've gotten that we consider for the idea is to consider right at like x equals 0.0001. If the parabola is below, it's never going to hit the circle again. If it's above, it's going to have to hit the circle because it's like inside the circle at that point and has to leave eventually. And so yeah, if a is greater than 1/2, then it intersects at 3 points.